Good morning, students. Now we are going to discuss the numericals of first chapter. I am taking few important numericals. This is one of them. Question number 1 is the electric field components are Ex equal to alpha x raised to the power of 1 by 2, whether Ey and Ez is 0, in which alpha is 800 Newton per kilometer square. Calculate number 1 the flux phi E through the cube, and number 2 the charge within the cube. Assume that A is 0.1 meters and this diagram is given. Means this is a cube, and according to given information we are having electric field along x-axis. Direction of electric field is along x-axis. Now we are going to find the flux through this cube. In this case we are dividing this cube into two parts, left face and the second one is of right face. Now first of all we are going to calculate the electric field due to the left face, which is equal to alpha, and left face is at a distance a from the origin. That is why in place of x we can put the value a raised to the power 1 by 2. We can write here as x is equal to a. Also the flux through the left face is equal to E dot del S. E dot del S by the definition of electric flux, where E is alpha a raised to the power 1 by 2, and we can first of all solve it as EL del S cos theta, and in this case electric field is from left to right along x-axis, and a normal on this face, perpendicular on this face is towards right. There must be an angle of 180 degree between them. Therefore we can put in place of theta as 180 degrees. Now we are substituting the value of EL is alpha a raised to the power 1 by 2, del S is a square, which is area of left face, and cos theta is of -1, which is equal to minus alpha a raised to the power 1 by 2 plus 2, means it is 5 by 2. Similarly we can write the electric field due to the right face, which is equal to alpha, right face is at a distance 2a from the origin, and then in place of x we can put the value 2a raised to the power 1 by 2. Similarly also we can calculate the flux due to the right face, which is again equal to ER del S cos 0 degrees, because this time the direction of the normal on the area and the electric field is same. That is why there must be 0 angle between them, and cos 0 is 1, then it is equal to ER del S. Now putting the values, ER is this one, this is alpha into 2a raised to the power 1 by 2, and del S is a square. Then it may be written as square root of 2 alpha a raised to the power 1 by 2 plus 2 is 5 by 2. Now we are going to calculate the net flux, which is equal to the flux due to the left face plus flux due to the right face, because the flux due to the electric field, flux due to the remaining phases becomes 0, because for other phases the angle between normal on the area and electric field is of 90 degrees. That is why cos 90 will be 0. So only these two faces, corresponding to these two faces, we can find the flux, and we have calculated. Now we are going to add them. Now phi L is equal to minus alpha a raised to the power 5 by 2 plus phi R square root 2 alpha a raised to the power 5 by 2. Now we are moving here. Phi is equal to alpha a raised to the power 5 by 2 may be taken as common. Alpha a raised to the power 5 by 2 is common. Then square root 2 is left here, and then minus 1 is left here. Now at last we can put the values of alpha and a raised to the power 5 a. The value of alpha is 800 and a is 0.1 raised to the power 5 by 2 square root 2 minus 1. Okay, now with the help of a log table we can simplify it, and we can write after simplification the answer is 1.05 Newton meter square coulomb raised to the power 1. This is the value of the flux. Second part of this question is the charge within the cube. We have calculated the flux. We are going to calculate the charge now. By Gauss's law, phi E is equal to Q upon epsilon naught. We can calculate Q as phi E epsilon naught, and the value of epsilon naught may be calculated by the formula 1 upon 4 pi epsilon naught, or directly we can write 8.85 10 to 12 also. It is 9 into 10 to the power 9. Then epsilon naught may be written as 1 upon 4 pi into 9 into 10 to the power 9. Therefore Q, net charge inside the cube, is flux is 1.05 multiply 1 upon 4 pi and 9 into 10 to the power 9, which may after simplification be written as 9.27 into 10 to the power minus 12 coulombs, and this